So this is DevOps episode number 1. And in this we'll be trying to cover deployments basically. So deployments involve several things such as Docker, Kubernetes, big data on Kubernetes, and a number of things. So we'll be starting with Docker first. Okay, then we'll gradually build our foundation towards that. So now you'll be thinking, Sachin, why you're bugging me with this Docker and all? Let me learn deep learning algorithm. That shit is cool. I do understand that. I do relate with that. But whenever I discuss this with my friends, they have some points and I do believe on those points as well. So I do understand that this deep learning thing is very cool. But there are many ML algorithms, as Srinivasan has rightly pointed out in one of his LinkedIn posts, that there are many ML algorithms that can even scale to huge data set. So even if you have very huge data set, you should not just blindly follow that, like, now I have huge data set, I should apply deep learning. Many times there are many ML algorithms which are very easy to like put it into production. They can be used for like they can scale to that huge data set. So that's one part. Now coming to the other part, why you need to learn about deployment. So as a machine learning practitioner, if you are, and even if you are working as a data scientist, you should learn about deployments. Why I should, like, in startup ecosystem, you have to maintain, you have to manage many things. So even if you develop your ML model, if you don't know how to put it into production, that's like what help it will do, like what problem it will solve, right? So that's why I think that you should know how to put your model, how to put your work into production. Unless it is put into production, it's not solving anything. So in that, this particular thing will help. Okay, so now I have written a blog a few days back, like a week or something, and in that I pointed out few points, basically 7 points, why you should learn Docker, right? So I'll just start with that. If you do not want to miss the content, because I'll be very regular now and I'll be releasing the other parts as well. So if you do not want to miss the content, please hit the subscribe button and hit the bell icon, so you will get the notification whenever I put any new content of this particular series. So let's say your one model requires a particular A value for one environment variable. The other model requires B value for that same environment variable. How would you maintain that? That's tough, right? Docker solves that for you. You can put one model in one container, the other model in another container, and can just, like, both will work independently. Like, one won't interfere in the other work. Issue solved, right? The second thing is different library requirements across the model. Let's say one of your model requires TensorFlow 1.4.0, the other requires 2.0. What will you do now? You can just put it into the container with one with particular TensorFlow 1.4.0, the another with 2.0, and both will work independently. No one will break another, like the other one won't break the other one. The third point is different resource requirement across models. So different resource requirement across models, let's say your one particular model requires GPU, right? And the other model, like there are like 10 models and one requires GPU, the other do not require GPU. They can run on CPU as well. Then why you want to mix all of them in one thing? You can just put the one which requires GPU in one container, the other separately. And you can make them run on CPU, and this particular one, the model which requires GPU, like by putting into a container associated with the Docker, that I'll explain in the in this video, what is container and all. You can just put it into that container and can associate the GPU with that. Case solved, right? Fourth point is scaling a particular instance. So let's say your one particular instance is used frequently, the other instances are not that frequently, or less complete, like when comparing both of the models. So you want to scale one particular instance, not the other instances. Now here Kubernetes and Docker will help you. So Kubernetes and Docker, you manage Docker container with the help of Kubernetes. That we'll discuss in future videos. But with the help of Kubernetes and Docker, you can solve this particular case. Now the fifth point is, you will say, why do I need to learn about Docker? I can just put I can use a REST API. I can put a REST API via Flask, right? You'll tell me that. But even if you go to the official site of Flask, they have this line in them which says that Flask server is not suitable for productions. So then what? The sixth point is if you do not want to screw your system for installing CUDA. So if you have ever worked with GPUs, you know what I'm talking about, right? So if you don't want to screw your system by installing all those stuffs, you can just maintain one container, one particular container which will have all those dependencies and all installed separately, and it won't interfere in your system. And the seventh point is when application is in different language. So let's say you have built a model which is in Python and your app is in like built in Go language, and now you want to expose your model to that particular thing. How will you do that now? Docker will help you in that. These were the 7 points, and now I think like why you need to learn Docker is somehow resolved. But if you still have some doubts, I have contacted few of the industrial experts who on their regular basis use Docker, Kubernetes and all those stuffs. So why not listen what they are saying, right? Here they go.
In order to train the model we have developed, we need data, the more the better, and processing power. At some point, we reach the limitations of our machine and we need to scale. That's where big data technologies such as Apache Spark and Hadoop have good chance to be used. Therefore, there is a need to set up and maintain a more complex infrastructure, which will be the role of IT operators. DevOps is a set of practices aiming at unifying development and operations. Therefore, it becomes a common ground between data science developers and IT operators. So, why is it important as a data scientist to invest in DevOps? Because we cannot work in silos anymore and we need to collaborate with IT operations to be able to industrialize the solution. In practical terms, this means versioning our configuration and infrastructure, investing in automating the training and testing of our models thanks to continuous integration, and the deployment with the help of continuous delivery and orchestration. I'd say your knowledge in DevOps brings a pragmatic approach, not only focused on developing the model, but also deploying and serving it to create value for the customer. So it's a step towards mastering the life cycle of an iteration, and it helps developing a more holistic approach of the whole delivery pipeline. This means having the ability to set up a scalable solution in a reproducible way, for example using Docker and Kubernetes. This way we are able to provide a common environment for the team and to deliver value more frequently, iterating over the refinement of the models and datasets. The main tool I use on my regular projects is Docker. It allows me to set up a reproducible environment and to distribute the software stack. Then I also use continuous integration solutions, for example Jenkins, using preferably a version declarative pipeline. I also use Kubernetes, which is really useful to set up scalable big data solutions. And finally, there are all the tools provided by cloud operators, object storage, for example, load balancers, message queues, which allow to rent computer resources without having to buy and set up a potentially expensive on-premise infrastructure.
Hello everyone. Today we are going to talk about Docker and Kubernetes in the context of data science. This is no way a elaborate tutorial on Docker and Kubernetes. You can read about it online, but what we will be kind of talking is how Docker and Kubernetes can accelerate a data science journey, right? But let me just give you just on Docker and Kubernetes. Docker is the most popular container environment, and Kubernetes is a platform for orchestrating container. Right. So what I mean is Docker basically allows your application to be packaged in a self-contained environment, and this particular container then can aid in quicker deployment as well as bring parity with your development environment. I will talk about it more in detail as we go further. Now, Kubernetes, on the other hand, can allow your container provisioning, can kind of automate your container provisioning, the networking part of it, the load balancing, scaling, and security part of it. So both go hand in hand. Now, when specifically it comes to data science, there are like five major benefits of using container and orchestrating using like Kubernetes. So if you see on the left-hand side, I have listed it out. You have multi-tenancy, tools and dependency, reproducibility, scaling, brew and canary deployment. Let us go into detail of each of it. So what do you mean by multi-tenancy? Typically, a machine learning model are pretty compute intensive task, and as your data grows, you need to invest in a huge cluster of hardware, and as well as like as you're training like complex models to accelerate, you may need devices such as GPUs, or even like if you're going to the cloud, TPUs, right? Now, this this is a pretty big investment for any company. On the other hand, there are really multiple AI initiatives going on in parallel, and it will not be ideal for every initiative to have their own hardware and invest an enormous amount of money on it. So this is where the Docker multi-tenancy comes into play. So basically, Kubernetes can isolate the environment per use case, and say you have a set of hardware, right? You have 100 node cluster, and you have like around 40 GPUs. So you can tell, okay, project A, you take around 100 cores of CPU and 2 GPUs. Project B, you take around 500 cores of CPU and 3 GPUs. So basically, you can isolate the resources using containers and Kubernetes. That is one part of it. Now, the second part is tools and dependencies. Now, if you take like and pretty much like a physical environment, your project team might have a requirement for TensorFlow 1.3, NumPy 1.4, or any kind of different versions of software. At the same time, the project B might need kind of TensorFlow 2.0. They want to work on latest on greatest. They need NumPy. They need a scikit-learn latest version. So basically, if you look at a physical environment, you are kind of creating a lot of virtual environments or Conda environments for every project. It becomes difficult to maintain. With container, you can package the entire tools and dependencies into your environment. It's like completely virtual for you, whereas the second project can bundle their tools and dependencies what is required, completely isolating it. So that's where the tools and dependency part comes into play. This both, if you see, is from the model training aspect of it. Now, what about model deployment? So, what a container offers is it allows you to package your entire training environment and then pass it on to an software developer to deploy it. Think like telling to a software development, I need like these 20 softwares and these 20 versions. Then the software developer going and installing everything, making sure the environment. Why not? Why not as you're training it, just take the environment, create a serving function alone, and flag the serving function, and then provide a container. Tell the software developer, okay, here it is. You deploy the container, and then you're good to go. It kind of accelerates the journey from your desktop to production. That is the third aspect of it, reproducibility. Scaling is another important aspect of it. If you see a typical retail industry, for example, on weekdays they may have like normal volume, but on weekends they may have 6 times or 7 times the weekday volume, right? And in the holiday season, when there's a huge sale going on, they may have even like 20 to 30 times the volume. Rather than having like those many instances of application up and running throughout the year, with container you can usually scale up and scale down your resources, right? That's actually more beneficial because you're allowing other application to use the unused resources rather than you occupying the entire slot. So container and Kubernetes is a good way of scaling your environment. The final one I'm going to talk about is blue-green deployment. Basically, once your model is deployed, how you can update to the new version or how you can do an champion challenger analysis. Let me do one thing. Let me quickly switch on to a different screen. So I'm sorry, just give me a minute. Yeah, I'm going to talk about a blue-green deployment as well as like a canary deployment. Now, coming specifically to blue-green deployment, think as a scenario where you have a new version of model, but your application is like kind of 24/7 by 365. You cannot kind of take down and deploy a new version of model. That's why the blue-green deployment comes into play. So a blue-green deployment basically is a way of accomplishing a zero downtime upgrade to an existing application. If you see my screen here, I have a version 1, that is my model already running in production and serving user traffic. And today I get a new version of the model, that is version 2. And what I do is I deploy that as a separate containers. And once the deployment is done, what I'm going to do is I'm going to kind of switch the traffic from version A to version 2. And this happens in a fraction of a second. No user is impacted. All the new traffic is gets diverted into your code version 2. This is one part of it. And in case you see like, okay, when you deploy the version 2, it's having some issues, you can always switch back to version 1. Now, the second part is canary deployment. What happens, like even before me, I deploying my version 2, I want to really take a small set of traffic and see how it behaves in the real world, right? That's where basically the canary deployment comes into play. And how the canary deployment works is you already have a user traffic serving the version 1. What we do is we introduce a version 2 to very few users, right? We validate whether okay the version 2 is performing better, and once you know it's performing, what we do is we completely switch on to version 2 of it. There are a few other deployments, but maybe in a later time I will discuss about it. Uh, to give you a kind of closing note, basically Docker and Kubernetes are really a valuable asset in your data science pipeline, both during the training journey and as well as the deployment journey. It is very efficient. It accelerates your complete model deployment journey and also brings in pretty much consistency in your model deployment. That's it. Thank you.
Welcome back. I think why we need to learn Docker is gone. So now we'll try to understand what is Docker. Okay, so before, like, I'm a storyteller. I love telling stories. So let's start with the story. And I have written the blog for this as well, and I'll put the links of all the blogs that I have written for this particular Docker stuffs in the video description. If anyone wants, you can go and see that. And also follow me on Medium. So if whenever I write the blog, you can like get a notification for that. Okay, so let's start with the story. So what's the story? I love Minions, and I think many of you will also love Minions. So Minions are character. If someone do not know, I'll like ask them to go and watch that movie. Like that's very funny. But let's start. Let's just not get deviated. What's the story? So if you remember, there like I think in the first part there was one villain, Victor, by the name of Victor, and so let's say he came back and he stole all the bananas that were there in the entire world. He kept them with him. He kept all those bananas with him. Now the minions, like, they can't live without bananas, right? So they thought to like they now they need to make a plan to get the bananas back. Then so one of the minion knew about the Docker technologies. So what he did, he broke down the plan into several steps. I'll just tell you the steps here. So what he did, he created first a recipe file. So what the recipe file basically had is like how to create a banana gun. What is banana gun? I'll explain later. So first he created a recipe file in which he mentioned the steps to create a banana gun. In the second step, they created a banana gun. What the banana gun basically does is that it creates like whenever that banana gun is pulled, like the trigger is pulled, it creates more bananas, that more artificial bananas basically. What those artificial bananas basically do, they go and collect the original bananas. Understood? Okay, I'll explain the steps again. First you have to create the recipe file, okay, in which you will mention how to create the banana gun basically. Then you'll follow the steps that are mentioned into that recipe file and create the banana gun. Now once the banana gun is like created, you don't want to use it right now, like you have planned for a particular date. Now you'll put it into the storage. Okay, when the particular specified date comes, you pull that particular thing, pull that trigger, and it will produce the bananas, artificial bananas. What that artificial banana do? They go and collect their original bananas, and then their work is done. So they'll die or they'll sit, whatever. They'll die basically. Okay, now how this is related to Docker, I'll explain. This recipe file is Docker file. Okay, so you need to create a Docker file first that will mention all the steps that is required to create the banana gun. Now what is banana gun? Banana gun is the image. Okay, what is image? Image is something which has been created by the Docker file, by following the Docker file. Okay, once the image is created, you put into the container registry. Why we need to put into the registry? if you put into the registry, it can be used by others as well. Like if you want your particular image to be used by others as well, you can put into the registry. The other can pull it and can use it. Okay. Now, after you put that particular image into container registry, now at that particular time when you want to use it, you'll just pull it, run that particular docker run command, and it will produce containers. So they're artificial bananas, which I said, they are the containers here. Okay, that will produce container. They'll perform certain tasks. Once their task is done, they'll die. Okay, I think that makes sense, right? Now we'll try to understand with another analogy. Okay, so if you are aware about mold, right, in which you are like, there are some different type of molds, like some are circular, some are like different sort of steps. Okay, so let's say you want to build a 3D image out of it. Okay, you want to build a 3D mold or something like that. So first you'll create a plan. How will you build that particular 3D print of that particular mold? Once that plan is built, you follow those steps that are mentioned into that plan and build up specified shape mold. Once that mold is built, now you can create, you can put it, you can store it into your some drawer or something like that, and once you want to make a cake out of it, you'll just pull it out, make the cake out of it and eat it. Cake are gone, right? So now I'll explain it into the terms of Docker. So the plan that you use to create molds is your Docker file. Once your molds are images. When you store it into some places, it is registry. Okay, and when you bring make cake out of it and eat it, so once the task of cake is done, it will die, right? So this has been this particular analogy has been given by one of my very dear friend. So that was there, and yeah, so I think for this particular video we have discussed a lot of things. First, why Docker? We have we discussed even with industrial experts that why they are using Docker, and then what is Docker with particular analogy. So this will build a conceptual framework. In the next videos we'll discuss more depth, we'll try to go in more depth about Docker, and we'll discuss some of the instruction set for that particular thing, and so that you can create Docker for yourself. You can containerize your application basically. Till then, goodbye.